Lesson 10, end of the course, data security. It's very important that we discuss data security in any courses that we take, especially in CS, so that you don't just build stuff and not care about security. I know security is not important when you're doing prototypes or building something fast, but somewhere along the line, you should already have data security in place, or security in general. So it's chapter 12, and we're gonna talk about more about network security, and we have to introduce the CAA triad later. Yep. So for network attack, it's basically an intrusion on a network infrastructure, and the first step to a network attack is basically to analyze the environment to exploit existing open ports or vulnerabilities. So if you're like military, this is your reconnaissance. You check for things first before you do anything. You can listen, you can plan, okay? So in network attacks, there's passive and active attack. A passive attack is basically gaining information, gaining intel, without alerting or disabling the system itself. And for types of network attack, we have a lot. These are just some. We have network sniffing, or also called packet sniffing. This is a famous one, the man-in-the-middle attack. MITM, the replay attack, which is a version of MITM. Denial of service, another version of this is distributed denial of service. Trojan horse, which comes from the methodology, or I don't know if it's history, when Troy and basically presented a horse as a gift, and soldiers were inside that big horse that was just built, and they were able to infiltrate. Session hijacking is basically getting the session. The cookie, phishing are the emails. We'll go in detail with these types of attacks. So for network sniffing, it's a process of capturing packets of data as they flow across a computer network. You've been doing this in your hands-on practice with Wireshark. There's tons of other tools that they can do, but Wireshark is already have a good functionality to see what protocols, what's coming in, what's the destination source, what packets, the source header. You can analyze everything. So you're already doing network sniffing. Sniffing involves inspecting, capturing, decoding, interpreting the information inside a network packet that flows on a TCP/IP network. Okay. The sniffing process could range from layer 1 through layer 7. If you're thinking about how about the physical layer, well, you can just attach a device, another LAN cable, and that itself would enable you to sniff from that network. And it would kind of look like this. Again, you're trying to sniff data that's passing in and out. Again, the packets. And there's different types of sniffing as well. We have the LAN sniff, which can scan the entire IP with internal LAN. We have the protocol sniff that checks what protocols are used. ICMP, TCP, UDP. ARP sniff, address resolution protocol sniff. It basically creates a map of IP addresses and associated MAC addresses. And then we also have TCP session stealing, which captures traffic between source and destination IP. Application level sniffing. Again, when we sniff those data packets, they would include application details as well. For web password sniffing, HTTP sessions are stolen and parsed for user ID and password stealing. Okay, again, Wireshark, you've done this. As you can see, source, destination, and protocols. You can see deeper on what the packet details are being sent and received. So spoofing is an act of disguising on a communication from an unknown source as being from a known and trusted source. So basically pretending to be someone else. Spoofing can apply to emails, phone calls, and websites, or it can be more technical, such as computer spoofing an IP address resolution protocol, or domain name system server. And kind of looks like this. In the basic level, instead of saying from the attacker, it will try to say, hey, I am John Doe and you know me. Okay? And in spoofing, we do have IP address spoofing, ARP spoofing, and DNS spoofing. So IP spoofing, you basically create IP packets and you modify the source address in order to hide the identity of the sender to impersonate another computer system or both. Again, changing the IP packet's source address. So it would look something like this. So instead of saying from the attacker, he would say I'm the victim as well, meaning the user, the trusted user, and he would ask the server to send me a lot of data, and then now the server would now send to the victim the data that he not requested, but the bot that requested that. Okay? So how do we mitigate IP spoofing? So one of the ways is to do ingress filtering. It basically rejects packets that are suspicious, i.e., let's say your source header does not match the origin. Okay? Address resolution protocol spoofing is a type of attack in which the malicious actor sends a falsified ARP message over a local network, and the result links of an attacker's MAC address with the IP address of a legitimate computer or server on the network. So again, this is spoofing, so it always tries to disguise as a trusted something. And it would look something like this. The attacker, it's also man in the middle attack. It goes from the middle, it intercepts that, and disguises. So as you can see, he would try to modify the ARP, and this one as well. So to mitigate that, better create a static ARP entry in your server, get a detection tool, avoid trust relationship, like do you trust this? No, just don't do that. Set up packet filtering. For DNS spoofing, it's also called DNS cache poisoning. It's an attack which altered DNS records are used to redirect online traffic to a fraudulent website that resembles its intended destination. It would look something like this. The attacker would hit this DNS server and would change the phone book. Let's say instead of Facebook going to, let's say IP1, Facebook goes to IP2, which that IP2, let's say, goes to a different web page. So here, let's say, again, client issues to a real website. Let's say I want to go to CDU. However, the attacker, let's say, comes from UW, and UW says, okay, I'll change that. Whenever people type CDU, it goes to the UW page. Something like that. And then again, you can change this caching in your operating system as well. I used to prank my friends with that. They type Facebook and then it goes somewhere else. So how do we mitigate that? So install security extensions with digital signatures and complex encryption, have active monitoring, check for patterns, and do DNS updates to randomize the ports. So man-in-the-middle attack occurs when a third party places itself in the middle of the connection. Kind of looks like the same, because most of them are a variation of man-in-the-middle attack. Okay. A variation of a man-in-the-middle attack is replay attack, also known as playback attack, in which they would get valid data transmission and they might repeat that request, repeat that request, or a delayed request. As you can see from this image, the man in the middle captures the message and later plays the message to Alice. Okay? So, denial of service attack. Attack in which the perpetrator seeks to make a machine or network resource unavailable to intended users by temporarily or indefinitely disrupting services of a host connected to the internet. Sometimes you would experience this when you try to access a website, web page, and it's down. One of the reasons is maybe they're doing some updates. Another reason that you may think of is maybe someone made a DOS attack, server gets overloaded, and now users can't access the server or make requests to the server. So a type of DOS attack, this is called the HTTP flood attack. If you have several computers, you can configure them to make a lot of HTTP requests to a server and basically overloading that server. Okay, now we talk about Trojan horse. Again, disguises malware as a legitimate piece of software, like a program or app or even a harmless document like a spreadsheet to trick users into willingly installing it on their computer. Anyone experienced this? Yes? Anyone? Experienced this a lot before. I think in the yeah, the 90s, there's a lot of Trojan horse malware, and that's one of the reasons I changed to Mac. Not because it's more safe, it's just because not a lot of people build virus or malware for Mac. That's one.
That's back then though, right? It's kind of changed now because
yeah.
people on the playground.
Mm-hmm.
But yeah, back then there was not enough Macs to even bother making.
Correct. It's like if I'm a hacker, it does not make sense to create and spend time, resources to make a malware for Mac that time, just because there's not a lot of users. There's no good margin to do that, right? But this was nasty. Like everyone's getting Trojan horse. Oh, I need to reformat my computer, right? And yeah, so it kind of looks like this. This shows you an example using the email. And when someone opens that email, that Trojan would now start up or boot up and contacts a server. This is just an example. And let's say that server, the malicious server, would now install a spyware and get to steal data, right? Again, Trojan horse has a lot of different ways. It can like change your data, can destroy stuff, and whatever the malware is built for. Session hijacking, also known as cookie hijacking, is the exploitation of valid computer sessions, sometimes also called a session key, to gain unauthorized access to information or services in a computer. So it kind of looks like this. Let's say I contacted Facebook.com and my session is now good. I have that cookie to store my session, so anytime I exit Facebook, open a tab within a time period, I can still go to my profile without having to log in again. So with that session, if you have someone, an attacker, stealing your session, he can now get to that same profile and access that profile. Because he's basically going to steal your login password and your session. So phishing is a fraudulent attempt to obtain sensitive information such as usernames, password, and credit card details by disguising oneself as a trustworthy entity in an electronic communication. This is very, very rampant until now. We are just luckier that now our email service provider has more, let's say, system or algorithm to tag them as spam. Well, before it's so hard to even know which is a phishing email or not. And the way it works is someone would send you an email and say there's an attachment, and you click that, it lets you proceed to a website. It might look like your Bank of America page, but it's not really that page. It's not the official page. And you start entering your user ID and password, and basically once you hit submit, or sometimes they can even see that session, they are now stealing your information. And yeah, they basically download your information. Like in my example, my mom from time to time would send me, hey, is this a legit Apple ID email that's requesting for me to pay Apple Store purchases. And we would always say, me and my sister, no, they won't request you for this and that. No, they won't request you for this and that. So again, the problem with this now, like people have been so good at copying the exact same website, making it look very legitimate. Hence, and that's why it's so hard. Another variation of phishing is the spear phishing, where instead of the normal phishing where I send everyone the same email, I would just target one person, let's say Sean, and Sean, let's say, loves cat pictures, and I start sending him cat pictures website. And then now when he clicks my link, I would then not attack first, right? Maybe plan something. And then now, next time I am more ready, I would use him as my, like my path to attack the entire system. He becomes the most vulnerable one, and he's like the weak link that I can attack. So spear phishing is basically targeted attack. Okay? So with all this security stuff, we have to talk about CIA triad. It's not the CIA government bureau. Okay? CIA triad basically has this triangle. The three of them is confidentiality, integrity, availability. It's being talked all the time, right? Confidentiality is basically the information must not be accessible by unauthorized individuals, entities, or processes. So example, if I have a grading system, I should not let anyone see it, right? Maybe just the student that I'm talking with. Integrity, the information must maintain accuracy and consistency over its lifetime. If I've given you a grade that's already final, that should not change. Let's say after spring or summer and it changed again, that's something that you don't want. Availability, the information must be available when requested. So when you guys ask for a transcript, it should be available and not say, oh, our network is down, we couldn't provide you your transcripts. So example of confidentiality is, let's say someone in the office says, our company is going to make 10% loss in Q4, and he doesn't want, this information should not yet be disclosed in the public. And then there's an attacker gathering that information, and now he said, okay, let me post that in the social media. And that itself defeats the confidentiality of your data. The next thing is integrity, okay? So he says the same thing. Our company is gonna make 10% loss in Q4, and the attacker, could be external or internal, changes to 0%, okay? Most of the people in accounting has the power to do this, change the values and make sure it balances out, less taxes. So that's an example of the data losing its integrity. Next is availability. Let's say on the other end, your boss wants to see those reports. So that's still confidential, that's fine. It's within your company network, but he can't get the data just because the network is down, or let's say the files weren't printed. That could happen as well. Here an example of, let's say, for the hardware, equipment is stolen or disabled, thus denying service. That's the easiest way if you're a bad actor. You want to deny service to someone? Well, just break their servers. For sure, they can't get access. Confidentiality, unencrypted CD-ROM or DVD-ROM or DVD is stolen. Okay, so let's say you have now USBs, right? So if that's something confidential, that should have an encryption that not anyone can read it. Okay, going for the software, programs are deleted, denying access to users. And confidentiality, an unauthorized copy of software is made. This is pretty rampant in the 90s as well with Windows licenses, PS1 games, PSP games. Integrity, a working program is modified either to cause it to fail during execution or to cause it to do some unintended task. So going to data, files are deleted, denying access to users. Confidentiality, an unauthorized read of data is performed An analysis of statistical data reveals underlying data. So with data, this is very important. If you're setting up your different departments like HR, sales, you don't want HR going into another folder, document, or even the cloud service, right? So HR should only have access to, let's say, employee records and not, let's say, the records of the sales. Doesn't matter to him, right? So with integrity, existing files are modified or new files are fabricated. Okay. Next, communication lines and network messages are destroyed or deleted. Communications lines or networks are rendered unavailable. For confidentiality, messages are read. The traffic pattern of messages is observed. A lot of this has been happening, let's say, like Edward Snowden, like leaking confidential files, falls under this one. Integrity messages are modified, delayed, reordered, duplicate, false messages are fabricated. Okay? And in terms of your day-to-day stuff, let's say your car, an integrity breach is basically your braking system stops working. Again, so integrity is something that should be doing something that you expect, but it does not go that way. Confidentiality breach is your braking patterns are exposed. So people can now know what's underneath the hood. Let's say your flight, integrity breach would be your plane's instruments reports that you are 1,000 feet higher than you actually are. So that's something wrong with the flight reading in the cockpit. Confidentiality breach, your flight plan is posted on internet. Note it already is. So I don't know if you guys still do this, so try to, as much as possible, avoid posting your flights in your social media, especially if you just leave alone, because it's a good way for other people to rob your home or steal something. So for the local power station, integrity breach, critical systems compromised leading to shutdown and catastrophic failure. Confidentiality breach is your electricity bill is published online, unless you want to do it on your own. Pacemaker, integrity breach, shutdown, and death. Confidentiality breach, your heartbeat becomes public knowledge, so that's HIPAA. Your home, integrity breach, your security system is remotely disabled. So this is a scary, scary thing right now, as we are more interconnected in our home space. If someone hacks you, it will be scary. Flipping light switches, especially if you have like the portal where people can just pop up with their face. If someone hacked that, it's super, super scary. Okay? Confidentiality breach, the contents of your fridge are leaked. You drink how much beer? Looks funny, but yeah. It would be great to see this if like, oh, these people hoard stuff.
That went into play too, saying like if all this is connected, like they can go back to your insurance companies too. Like,
Yep.
why you drink as much beer, we're raising your premiums and whatnot. So it's kind of a scary world.
Yeah, and again, how insurance companies calculate your premium is basically they have this table. Are you smoking? Are you drinking? Are you blah, blah, blah? Are you married? Yeah, it's basically they're trying to quantify an unquantifiable thing, which is a person, right? Which is scary. So for security services, again, it's the same. We have the authentication, data integrity, confidentiality, and non-repudiation. Non-repudiation basically means that when you do something and you have, let's say, your signature there, it should not be altered, right? So moving on. So symmetric crypto systems, we're going now to encryptions. We have data encryption standard, DES, which is kind of old school. We're now in the advanced encryption standard, which is AES. And this is an example. So let's say there's an unencrypted message, and what happens is you would be given a public key. This is a form of, let's say, a large prime number. Include that in your message, becomes encrypted, right? And you send that over the non-secure network, so not everyone can know what you're sending. and then when the receiver receives it, he has this private key that allows him to unlock that lockbox or that encrypted message to decrypt it and now understand the message. So, symmetric crypto system disadvantage over public key crypto system is basically not suited for encrypting long messages, longer time than symmetric, generate ciphertext larger than plain text. Let's see. So, as part of the crypto system that we have to talk about is RSA algorithm. It's kind of technical. Let's go over and let me show you an example. So right now, let's just read through this. RSA is to find three integers d, e, and n such that d and e are inverse modulo phi of n, where n is the product of two prime numbers p and q, that is n equals p times q. Such number exists, then e, n can be encryption, the encryption, which is the public key, that is published, and dn will be the corresponding decryption, the private key, that is not published. Let m be the message or the plain text to be encrypted, and c be the corresponding ciphertext. If d and e are inverses modulo of phi n, then it can be shown that if c is generated by the operation, and this is an example of the digital signature generation. So again, you have the message, you have your hash function, you add them up together, becomes the message digest, and now you add up the private key to create your digital signature, and now you send that same message again to the recipient. To verify that, when the recipient has it, so again, this one, message being encrypted, now it was sent to the recipient. Now from the recipient, how can he verify and decrypt it? You'll basically need that hash function. Your hash function basically has this a big number or a big hexadecimal code to decrypt that, and also has the public key. And now once it has the decryption process starting, it can either accept the message or reject. Again, why? Because it would check if it's identical with the other one or not. So this is the IPsec security in tunnel mode. Let's skip this. Transport mode. So Muddy's point, could we talk a little bit about ECDSA and IP security? Didn't quite understand the overview of IPsec or what is gained from it. So ECDSA is basically another encryption process. It looks like that. It also uses the hash function. It's faster than RSA for signing and decryption, but it's slower for signature verification and encryption. Moving on. What are the differences between the authentication header AH and the encapsulation security payload protocols of the IPsec? Well, AH protocol does not provide data encryption. What else? AH can be used to provide authentication and data integrity in communications that do not need encryption. AH alone can be used when no encryption is required for the data, but ESP with null encryption can also be used to achieve the same purpose. So for ESP protocol, it does provide authentication, encryption, and integrity checking to provide secure data transfer. Okay, so as a general guideline, use ESP for any normal VPN tunneling. Can digital signatures prevent network attacks? Not really, only because the certificate authority, which is the one giving the digital signature, when you click HTTPS, you click the certificate, you would see that, right? A digital certificate. And a certificate authority is the one issuing that. However, even the certificate authority is vulnerable to attacks, so it can be a malicious third party that's sending fake certificates. So it's not really that secure. My laptop once got attacked when I used Google search engine to find a website. It directed me to the results were found by Yahoo search engine. In this case, is it considered a DNS spoofing? If so, who's the attacker? I used to wonder if it's Yahoo that altered my system. Any guess?
I mean, I think it is DNS spoofing, but I don't think Yahoo did it.
Yeah, that's my thought as well. Could be someone messing with your DNS cache, or maybe someone attacked Google or Yahoo. We don't know. That's a problem. Usually we know that it's redirecting you, it's doing something wrong, but unless someone announces what's really happening, it's hard to know. Unless you're a security firm doing this monitoring, or you're in the big tech doing the monitoring of this stuff. So it's really hard. One thing that you can do maybe is clearing the cache. So you go to a different DNS server to contact them. Maybe go to a legitimate DNS server. Yeah. What else? How would I implement RSA algorithm on the job? Will I execute this algorithm in the terminal? How will I know if the code and algorithm works? You don't want to do this on your job because it's not your expertise. You usually find a, let's say, crypto API provider. Because again, if I'm releasing a prototype, sure, no security. But once I get bigger, I should implement some security. But if I waste my resources within my own company to implement my own RSA algorithm, there's a high chance that I may implement it wrong and expose user data, right? I'd rather have to pay someone, a vendor, a third party, to say, hey, can I use your API so that I can have encryption? So that's what you usually do. And this is the end of the slide. I'm gonna quickly show you the RSA stuff. Let's see. So last time, I remember we had, in my class before, we had a research project that we have to talk about RSA. So that hopefully this is a clearer version. First step is you generate a key. You choose 2 prime numbers, large prime numbers. Then you compute that product. Again, the n is the modulus of the private and public key. And now you calculate the TROJAN function or phi. You use both the large prime number, okay? So again, most important concept with RSA, you have 2 large prime numbers first, okay? And then make sure that you choose another integer called e, and they should be co-prime to the TROJAN function. Again, your TROJAN function includes the x and y, so the e should be a co-prime to the x and y that you computed. So e is the public key exponent used for encryption. Now choose a d so that e times d mod TROJAN equals 1. So that verifies if they are a co-prime or not. Okay, moving on. So how to encrypt? You basically has your m as the message, and you raise that to your n, then mod n, and this is now your encrypted message. For your decryption, you would now have your encrypted message C and raise that to D, then mod N to bring you back to that message. So the steps for this program, when I execute it, I would first set first prime number, then set second prime number, compute the product of the 2 large prime numbers, compute the phi using the first and second prime number, set an encryption number, and make the encryption number a co-prime, which is E. Set the message to be encrypted. Start encrypting the message with the encryption number. Compute for the decryption number using encryption number and phi. Prepare for decryption by operating the encrypted message and decryption number. End of encrypting the message with encrypted message and product of primes. Complete setup for decryption, and just print them out. So yes, we did have a chance before to create our own. implementation, and this is how it looks like. So you have your P and Q as your two not that large prime, just to showcase. And this is your product, this is your TOSHET function, this is your E, C, and D. So it basically works like this. If I have any message, it could be a text, let's say 9, and my encrypted message would be something like this, which you don't know. But if I have the decrypting message or function, I should be able to have the same value afterwards. So again, to simplify it, you have a message, you encrypt it, make it garbled message or whatever, so that it's harder for the other person to decrypt it, and then, unauthorized users to decrypt it, and the intended user should have an easy time to decrypt that message. So with the RSA, I think it takes a lot of time to, let's say I'm an attacker, to decrypt that. However, now with quantum computing, people can just use their processing power to compute this large sums of value. So people just think that, oh, it's just a large coprime. No, it's so hard to decrypt, just because you have need to have a lot of processing power.